Deep in space, pulsars shine like cosmic lighthouses, spinning with incredible precision. These remarkable dead stars teach us about gravity, space, and time. Join us as we explore these fascinating celestial objects and their mind-bending properties. Let's rewind to the dramatic moment when a pulsar is born. It starts with a massive star, much bigger than our Sun, running out of fuel. When this happens, the star can't hold itself up anymore, and in just a few seconds, its core crashes inward, while its outer layers blast outward in a spectacular explosion called a supernova. What's left behind is a super-dense ball of matter about the size of a city, spinning incredibly fast. That's our pulsar. Imagine squeezing an entire star into something the size of Manhattan. The material is so tightly packed that a spoonful would weigh as much as several million elephants. As this newly formed pulsar spins, it shoots out beams of radiation from its poles, like a lighthouse beam sweeping through space. Now, let's look at how pulsars create their famous cosmic light show. These spinning stars have powerful magnetic fields that channel radiation into two beams shooting out from their magnetic poles. As the pulsar spins, these beams sweep through space like a lighthouse beam sweeping across the ocean. When one of these beams points toward Earth, our telescopes detect a pulse of radiation. That's why we call them pulsars. These pulses are incredibly regular, sometimes more precise than our best atomic clocks. The beams contain different types of radiation, from radio waves to X-rays, and even gamma rays. The faster the pulsar spins, the more frequent the pulses we detect. Some pulsars spin hundreds of times per second, while others are more relaxed, taking several seconds between pulses. The timing of pulsars is so exact that it puts even our best watches to shame. These cosmic clocks spin with such perfect rhythm that scientists can predict their pulses down to the microsecond. Think about this. If a pulsar started spinning when the dinosaurs roamed Earth, it would only be off by a few seconds today. This amazing precision makes pulsars perfect tools for testing Einstein's theories about space and time. Scientists use them to measure tiny changes in gravity, study the space between stars, and even help spacecraft navigate. They're like natural GPS satellites scattered throughout our galaxy. Some pulsars are so reliable that astronomers use them to search for gravitational waves, ripples in space itself. Sometimes pulsars find themselves in an incredible dance with another star, creating what we call a binary system. Think of it like a cosmic waltz, two stars orbiting around each other, but one of them is our super-dense, rapidly spinning pulsar. These pairs give astronomers a perfect chance to study gravity in action. When a pulsar orbits with another star, or even another pulsar, we can track their movements by watching how the pulsar's regular beats change as it moves closer to and farther from Earth. Some of these pairs are so close they'd fit inside our Sun, whirling around each other in just a few hours. The most famous binary pulsar helped prove Einstein was right about gravitational waves, showing that two objects in space can create ripples in space-time itself. Let's talk about the speed demons of space, millisecond pulsars. These incredible stars spin faster than your kitchen blender, rotating hundreds of times every second. Imagine a star the size of a city whirling around faster than a helicopter's blades. These super speedsters got their incredible spin from stealing material from nearby stars. As this stolen gas and dust falls onto the pulsar, it acts like a cosmic speedway, making the pulsar spin faster and faster. The fastest one we've found spins 716 times per second. That's almost as fast as some car engines. These rapid rotators are also some of our most reliable cosmic clocks, helping astronomers measure time and distance in space with amazing accuracy. When pulsars spin, they don't just send out beams of light. They create beautiful cosmic clouds called pulsar wind nebulae. These glowing clouds form when the pulsar's powerful magnetic fields shoot charged particles into space at nearly the speed of light. The most famous example is the Crab Nebula, which looks like a colorful cosmic spider web in telescope images. Inside this cloud, particles are moving so fast they crash into each other and create a blue glow we can see from Earth. The nebula keeps growing as the pulsar pumps more energy into it. like a cosmic fountain that never stops flowing. These nebulae are like nature's particle accelerators, creating conditions we can barely match in our best laboratories on Earth. Pulsars serve as perfect natural laboratories for testing Einstein's theories about gravity and space-time. These spinning stars move through space in ways that let us see Einstein's ideas in action. When pulsars orbit close to massive objects, their precise timing signals change slightly, showing us how gravity bends space. Scientists have used these changes to confirm that time moves more slowly in stronger gravity, just as Einstein predicted. They've also helped us spot gravitational waves, those tiny ripples in the fabric of space. One famous pair of pulsars showed their orbit was shrinking exactly as Einstein's math said it would, as they lost energy by making waves in space-time. It's amazing how these distant lighthouses help prove one of science's most important theories. Some pulsars take things to the extreme, becoming what we call magnetars, the cosmic kings and queens of magnetic fields. These rare stars have magnetic fields so strong they would instantly erase every credit card on Earth from a distance halfway to the moon. When magnetars have starquakes, they release more energy in a second than our sun does in thousands of years. Their magnetic fields are so powerful they can actually warp nearby atoms into strange shapes. These space oddities can suddenly blast out huge amounts of energy in massive flares that we can detect even from other galaxies. While normal pulsars are impressive, magnetars are like their supercharged cousins, showing us just how extreme the physics of dead stars can get. The steady beats of pulsars aren't just fascinating, they're also perfect for space navigation. Just like sailors used lighthouses to find their way across oceans, future space travelers might use pulsars to navigate the cosmos. Each pulsar has its own unique spinning pattern, making it easy to identify, like a cosmic fingerprint. NASA has already designed spacecraft systems that could use pulsar signals to figure out their location anywhere in the solar system. By measuring signals from several pulsars, a ship could calculate its position with amazing accuracy. It's like having a GPS network built by nature, spread across our entire galaxy. Even the Voyager space probes carried maps showing Earth's location relative to major pulsars, just in case alien civilizations ever find them. As we look ahead, pulsars might help us solve some of space's biggest mysteries. These cosmic timekeepers could help us spot gravitational waves from the early universe, giving us a peek at what happened right after the Big Bang. Scientists think a network of pulsars across our galaxy might work like a giant detector, sensing tiny ripples in space from colliding black holes or even cosmic strings. Pulsars might also help us understand dark matter, that mysterious stuff that makes up most of the universe but we can't see. By watching how pulsar signals change as they travel through space, we might find clues about what's really out there. They could even help us test whether gravity works the same way everywhere in space. Thanks for joining us on this incredible journey through the world of pulsars. These cosmic lighthouses continue to amaze scientists daily. If you enjoyed learning about these fascinating objects, hit like, subscribe, and share with your space-loving friends.